Welcome back, students. In the previous video we studied that only CE configuration is suitable for amplification. But the problem with the CE configuration is input impedance and output impedance. Generally, for a good amplifier, input impedance should be very high. Output impedance should be low. These conditions I explained already. But if you see CE amplifier, its input impedance is very low. Output impedance is high. We need to change this scenario. For that, we are introducing a concept called as feedback. Guys, if you consider a normal resistor, let it be of 4 ohm. To increase its resistance, we will add another resistor in series. Now it will become totally of 8 ohm. To decrease its resistance, we will add another resistor in parallel. It will become 2 ohm. If you observe here clearly, if we add in series, resistance is increasing. If you add in parallel, resistance is decreasing. The same concept we will apply to feedback also. If we suppose this is our amplifier, this is the input, this is the output. Our input impedance should be high. So if we add an element in series to the input, its input impedance increases. If we add an element in parallel, its input impedance decreases. Similarly at the output side, if we add something in series, its impedance increases. If we add some element in parallel, its impedance decreases. Now keep this explanation aside for some time. We will learn what is feedback. Feedback is, guys, nothing but taking some part of the output, taking some part and multiplying it with some gain and giving it back to the input. Generally taking some part of the output and comparing with the input, that is called as feedback. Now, guys, if you observe, we have two kinds of signals. One is voltage and one is current signal. If this is our output, to sense the voltage, let this be V. To sense the voltage, we need to take our terminals from these two wires, right? What I am telling is, you need to take a voltage sensor and you need to sense the voltage from these two wires. Indirectly, you need to sense voltage parallelly. See, if you keep your voltage sensor here, it cannot sense the voltage. Why? Because voltage is between these two terminals. You should keep the terminals of the voltage sensor, one here and another terminal here. Then only you can sense the voltage. Indirectly, we are applying an element parallelly to sense the voltage. This is what I want to say. So if you want to sense the voltage, an element is applied parallelly. Next, you want to sense the current now. See, these are two wires. If you want to sense the current flowing through these wires, you need to keep your current sensor here. You cannot sense the current between these two lines. In these two lines, voltage will be there. From each line, current will be there. So if you want to sense the current, you need to keep your current sensor here or here, your wish, in any line. Indirectly, what I am telling is, for sensing current, we are applying a element in series. For sensing current, we are applying a element in series. Now, what we are doing? We are taking a sample of the output. So taking the signal is called as sampling. Now come again. We have two kinds of sampling. One is voltage sampling, one is current sampling. If you are sampling your voltage, you should apply your terminals in parallel. This indicates that if you are applying something in your parallel, its impedance decreases. So output impedance decreases. While coming to current sampling, you should apply your current sensor in series. If you are applying some element in series, what will happen, guys? Your output impedance increases. In this case, our output impedance increases. So you got clarity, right? Taking something from the output is called as sampling. There are two kinds of sampling. You can take voltage signal or you can take current signal. If you take voltage signal, you should apply in parallel. Then output impedance will decrease. If you need current signal, you should apply in series. Then our output impedance will increase. After sampling, we should mix the signal with the input. What I am telling, we should mix the signal. So taking the sample from the output is called as sampling, and mixing with the input, the name itself indicates, it is called as mixing. Now what are the signals we took? One is voltage signal, another one is current signal. So we should mix these two signals with the input. First we will come for the voltage. If you see voltage signal, we should mix the voltage signal in series. We cannot mix the voltage signal in parallel. Why? If you mix the voltage signal in parallel, there are already some sources. Suppose this is 2 volt. The voltage what you sensed is suppose 0.5 volt. There are already some voltage sources in parallel. It is the violation of KVL. Results in the large currents. So this is wrong thing. What you should do is, you should mix the voltage source in series. See, if you mixed like this, then it is okay. Suppose it is 0.5 volt. The total thing will be 2.5 volt. Conclusion is, voltage should be mixed in series. But while sampling, elements should be applied in parallel. While mixing, elements should be applied in series. Remember that. So voltage signal mixing, it is in series. It indicates that input impedance increases. Next. Similarly, while mixing current, you should apply current in parallel. If you apply current in series, what will happen is, the all elements will get affected. Because in series current flow will be same. Previously there is some current flow. If you apply another current in series, the all elements will get affected. But that should not happen. What we need is, if there is 2 ampere current flow, we need to add to that 2 ampere some 0.5 or 0.6, so that it will become 2.5 ampere. If you apply in series, suppose there is 2 ampere flowing in this circuit. If you apply in series 4 ampere, this 4 ampere will not add to that 2 ampere. Instead, the whole circuit will carry the current 4 ampere. So current source should be applied in parallel so that it can add the currents now. So what is conclusion here? Current should be applied in parallel. Current should be mixed in parallel. If it is mixed in parallel, our input impedance will decrease. So guys, what is our first action? Sampling. What is our next action? Mixing. This name is also given according to this. Our first action is sampling, second action is mixing. In sampling there are two types, voltage sampling, current sampling. In mixing also there is two types, voltage mixing, current mixing. If you come to voltage sampling, you should apply element in parallel to sense the voltage. That decreases output impedance. And you should apply element in series to sense the current. That increases output impedance. While coming to mixing, to mix the voltage, you should apply element in series. That increases input impedance. While current, you should mix in parallel. That decreases input impedance. Based on this, you have 4 kinds of feedback. First one is voltage sampling, voltage mixing. Voltage sampling, current mixing. Current sampling, voltage mixing. Current sampling, current mixing. Sometimes they can change these names. Instead of voltage mixing, they can say series mixing. Instead of current mixing, they can say parallel mixing or shunt mixing. Instead of voltage mixing, series mixing. Instead of current, shunt mixing. Similarly here also, instead of voltage sampling, they can say it is shunt sampling. Similarly here, shunt sampling. Current is series sampling. So you need to remember these basics. If you take current signal, what will happen, what is sampling, what is mixing, how to increase the input impedance, how to decrease the output impedance. You need this much of basic to understand the feedback amplifiers. In the next lecture, we'll proceed into depth. So that's it for now. If you like my explanation, do subscribe to my channel and hit the like button if you like this video. Thank you. Meet you in next lecture.